Yeah, yeah, we can see it. We can see it
Yes.
now.
Right. Okay. Okay. So I think I have one of my colleague also in this session, so we can discuss. Anybody has an have worked on Hadoop before?
No, no, we haven't. I haven't worked.
You have anybody else who has worked on it?
No.
Nope. At least you have any idea what a Hadoop is or something like that?
Yeah, from your videos we have, the videos you have shared.
Right.
I have a brief idea of what it is.
Okay. Just give me a minute.
Yeah, so
Right. So okay. Okay. So in the videos that I had posted, I think um, 1 second. Many people are, I think they're joining, couple of people. So yeah. I think previous and all I had completed all the other videos that I mean, like in the previous videos and all, I had incorporated this the HDFS and related to the Hadoop ecosystem. But the thing is, we never discussed what actually how the HDFS is. So if you have any idea, or if you have worked on any other platform, or have you did anybody work on any cloud platform where which is using storage as a structure?
yeah.
Like
Yeah, Manoj, sorry to interrupt. I mean,
yeah.
when you asked the question that any of you have used HDFS, I thought of answering, but yeah,
He was on mute. Okay.
modern, modern day, I mean, cloud infrastructure provides similar kind of concepts. See, not similar, the exact concept
Okay.
in different terminologies like ADLS or it might be S3. So they use the backend HDFS architecture itself. So yeah, we have used.
That's right. That's where I was actually wanted to go and head out. So if anybody had used S3, if anybody are using S3 right now in AWS, or if anybody are using Azure Blob or maybe ADLS, they are indirectly are the grandchildren of the HDFS. That's what I actually meant. So right. Um, So if can you guys tell me where in which kind of a project you are allocated to, so that I mean just a gist, like maybe what kind of technology your project is using. Probably we can discuss what they should have done, they could have done, or they might have done. We see it's just a discussion. Nobody cares whether they do it or not. So I'll tell you about mine. Okay. So the project in where I'm working on, they have this cluster, they have this MongoDB cluster in the AWS, but the processing which is happening is in Azure. Now you might be thinking that why, Manoj, why do you really think that I mean, MongoDB is in AWS and you are doing the Databricks, whatever this processing, what do you call this, ATL and ELT or whatever you want to do. You might ask me, what are you using? So I'll tell you an answer that no, yeah, we are using Databricks for transformations and action and processing the data. Now you'll ask me, where is the Databricks? Now I'll tell you it is in Azure Databricks. That means it is in Azure. So you'll be like, Manoj, why is this? Why this Azure? You're using the Databricks is in Azure, but the source for the data in which you're in which you're going to pull is in AWS, that is in MongoDB. Don't you think there will be a network issue? There will be a latency. Don't you think that's yes? I'm going to answer all these questions, but first let me tell you how the data looks like. I mean, how the process is. So we pull the data, we do the transformation, and we store it in delta table, that is ADLS Gen 2. So this is how the project looks like in the project in which I'm working on. I know you can say that there is we could have used ADF, Azure Data Factory. We could have used me in the AWS itself. Why to come to like Azure? Why pay two different cloud providers? See, similar to ADF, there is glue in the AWS. Everything you could have done it in the glue itself. Why? So, but we'll keep that discussion to another. These questions I'll answer in the later part. But I'm going to tell you, I'm going to stop here how this project looks like, and I'm going to give you a chance where you guys let me know what how your project looks like, so that we can discuss what they could have done. Anybody wants to take up a stand and tell? Or maybe if you have used it in previous project which looks fine, I mean, however it is.
Sorry, Manoj, what was your question? I missed it.
How does the the project workflow, the functional point looks like I said, my data comes from MongoDB, that is in AWS. Then it comes
Yeah,
to
okay.
Azure Databricks, where we are doing the transformation, and then we are storing it in ADLS Gen 2. So how about you, like how you guys are doing?
Yeah, similar kind of setup. I mean, in our project, they will get the data from REST APIs, I mean, different web servers, and they will store it into S3. So that is the primary, what we call first step. Okay, once the
Okay.
data is loaded into S3, they will spin up EMR clusters to process the big data, and then they will push it to the different kind of setup, like it might
So they
be
have EMR, so they are invoking the virtual machines. They are on demand only, right?
on demand, and also they are spinning up on Lambda.
Oh, they're
So
spinning it on
AWS
Lambda.
Lambda function. So it's all, I mean, for different workloads, we spin up a Lambda, or if the workload is more, I mean, if you have to deal with the petabytes of data, then they will go with a Spark job, like EMR clusters and all.
Where are you writing
And then
Spark jobs? Like the code, the Spark coding?
usually it will be in notebooks. I mean, EMR cluster provides a Jupyter kind of notebooks, and then they will try to write the code inside that, and then they will invoke the. It's similar to kind of Azure Databricks. So Azure Databricks provides a separate, I
Yeah.
mean, integrated notebook with them, but EMR is not like that. I mean, they will provide a kind of a notebook similar to Zeppelin, or
Yeah.
you can make use of Zeppelin, or what you call Jupyter notebooks as well. And then you can
So
write a code, or else you can bundle it into a code or
exactly. So
jar
that
files,
was my
and then
question actually. So you could have done that, and people would prefer, which is good, doing it in notebook or see Lambda is I believe Lambda is a serverless, right?
yeah, Lambda is a serverless. Yeah,
Yeah.
it depends on. I mean, it's a choice. You know what? If the if you are from a traditional background, right, you will try to build up a jar files, and then you will try to submit inside a Spark submit job, and then you will invoke the function. I
Yeah,
mean, you will
that's
spin up
yeah.
the Spark clusters. But nowadays,
Correct.
what industry is moving on is, right, they're trying to uh, ease out the developer efforts. I mean, whatever the efforts the developers have to put in, right. So everything the company is trying to uh, make a use. I mean, the burden on the developers is they are removing it. So they are making use of interactive clusters or interactive notebooks, and then we can all the teams. It might be from data science, data engineers, or machine learning model engineers. Or they can in a single place they can interactively query the data, or using notebooks. So that is the advantage of using modern notebooks. Either it might be Azure Databricks notebooks, or it might be Zeppelin, or Jupyter notebooks. So yeah, many of them are now preferring to go ahead with the notebooks only. Then but
Yes.
yeah, if someone is sticking to the traditional way of doing it, they might use Maven files or jar files, and then they will bundle it up, and they will invoke a Spark job. So
Yes.
the flexibility will be more if we do it in a jar files. I mean,
Yeah.
flexibility in the sense of configuring the clusters and Spark, fine tuning it. But yeah, notebooks,
Always there
yeah,
will
it
be
comes
ups and
with the
downs,
same.
right? In both
Yeah,
sides, because obviously world wants to move to the cloud, but at the end, see,
mm,
if see what you said, I understood, but I'm not sure if it gave the same impact to others as well. What Manoranjan wanted to say is we have a traditional way of building the cluster, and we have cloud, which I also mentioned in the previous video. I think I had in my previous video on YouTube, I mentioned what is on premises and what is cloud, the difference. The on premises is the company is going to get, are going to contact Hortonworks company or Cloudera company. Anyway, Cloudera and Hortonworks merge together anyways nowadays now. So there is only two companies, that is Cloudera, Hortonworks, that is one, and Map or something, I don't know. So they provide the servers, and they are going to get their servers, transport it to the location where the company is, and they're going to have a separate room or a floor, put all ACs, and then build the servers. That's the cluster actually. And cloud is anyways, cloud is a cloud, that means Azure or AWS have taken like acres of land, and they are going to build a cluster over there for everybody across the world. So one is in Ahmedabad in Mumbai, near to like our Amazon is in there, the one of the cluster that is in Asia Pacific, South India, maybe, I don't know. So what Manoranjan wanted to say is, when they have two opportunities. There is something called Spark Submit, where you write the code of all the Spark, and you need to download all the jars, and you need to, it's similar to selecting few folders and zipping it in WinRAR or 7-zip function, like like in the Windows. So you are going to zip it and bundle it and then give it to the cluster. You know what, cluster, take this and just run it. This is on premises. But nowadays, like Manoranjan said, it is the cutting edge technology is not working like that. It's like you are going to create some function called lambda function in the AWS, and lambda function takes some arguments, not arguments, kind of it 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 needs something to load, because it's you're in the on premises, you're giving the code in a jar file. Here also you're giving it in a zip file, but the thing is, it's going to take the resources from the Amazon itself. And like I said, you might get confused, what is this Manoj telling serverless or server, and what is Manoranjan telling EMR. EMR is, see, elastic map reduce, that's kind of a it's a virtual machine that's going to be present, that is easy, like elastic cloud computing. It's, there's a cluster which will always be there, dedicated cluster, it's going to be there, it's on demand. And there is something called spot instance. There is some on demand instance is different, and there is spot instance. On demand is the cluster will be given for the company is going to pay the money, and forever, I mean, as long as they're going to pay. Let's say that I want to use this cluster for 5 years. So anytime developer wants to come at 12 o'clock, 6 o'clock, 9 o'clock, night, morning, day, afternoon, anytime he can use that cluster, that will be on and running. Spot instances is nothing but when the job is running, it feels that it needs to take some of the resources. When I say, it's computing, okay, computing or memory or something, it's going to grab from somewhere from the Amazon and runs the job and gives it back. That's it. That's how it is. Use and throw, something like that. If you tell serverless is this, so Lambda is a serverless. So this is how companies are, building, save, I mean, cost cutting, right? If you use it for only certain number of time and then give it back, so why you want to pay crores of rupees for having it installed in your machine? That's what it means. So it's a good, nice setup in Manoranjan's company. That's, I like this approach, because you have more control over it. And also Manoranjan told that more control and more flexibility is there in the Spark Submit that is on premises. Why in spite of having cloud, you have some control is, when you're doing Spark Submit, you can actually mention the executor memory, the worker memory, the number of cores that needs. All these are the parameters which you're giving. Spark Submit, the class name, and then you're going to give hyphen executor hyphen memory, let's say 20 GB to 20 gigs, like 20G, then hyphen worker node is 8, that means 8 worker node will be there. And then finally you're going to give the path where the jar file is located. The jar file is nothing but all the Java, the jars that is supporting libraries, which you can say. And then when you submit this gets bundled and it's going to go to the cluster and on premises. So this flexibility is there in on premises, but still anyways you can still do it in cloud. It's not that you cannot do it in cloud, you can still do it in cloud. So this is how it is. But then the whole agenda of this session was actually HDFS. So how is this S3? And S3 is a, what do you call it? It's a data lake, we call it. It's a data lake. And in Azure, we have ADLS, Azure Data Lakes system service, or Azure Blob, which was also there, which is there actually right now. And nowadays, the ADLS comes under the Blob. So Blob is nothing but a folder, as simple as that. There's nothing to confuse. In Azure, there is something called Azure Blob. A blob is, just imagine that it's like a bubble, a blob that stores something. That's it. It can store a folder, it can store a file, it can store anything, everything and anything, image, video, everything. It's just like your Windows folder. That's it. But how is it different? If you think that is the same, no, that's not the same. There is only small difference. So it is similar to HDFS. The cloud people derived these things from HDFS. But I'm going to save that thing for, we have another 9 minutes. Let's wrap this up. We'll give another one people who, if you want to tell, if you have worked in any project that involves like this. If not, then we can discuss on HDFS and let's wrap this up. Anybody has worked on cloud or using this kind of service? Yeah,
in our current project, like we're using Azure Databricks for the transformation purpose, and in the transformation we're using PySpark and SQL and Python. And when it comes to this pipelines and data pipelines thing, we are using Azure Data Factory. And for the storage purpose, we are using this Blob and ADLS.
Okay, so it's well within the Azure environment itself, everything.
Yes.
Just one question: why ADF and Databricks? Both of them, more or less, it's gonna do the same thing. Like, you can either do it in Databricks, you can either do it in ADF. But ADF, you do not have much control, because if you want dropping the columns, certain transformations, more flexibility is there in Databricks. If you're anyways going to use Databricks, then why ADF?
Oh, for the data pipelines, I mean, like for the transformations, they'll be using Azure Databricks, and for the data pipelines and all the storage purposes, they'll use Azure Data Factory.
You mean, do you mean to say orchestrating the pipeline, or?
Yes, orchestration.
Yeah, maybe you can also tell your, like in your company, that we don't need to use ADF. We can actually do the orchestration from the Databricks in the recent version from 9.1 or maybe 7.1, 7.3 also LTS. They give you an orchestration for the jobs as well. You don't actually need ADF for that. Maybe if you pitch this idea, maybe you can research for a couple of days. Now, what I'm saying, maybe you can convince them, you can give an approach. Probably it gives a good rapport with your manager that you're doing, you're researching something. It will be a good helpful for you in the project, making an impact in the project, right? Because even I didn't know this until recently. In Databricks, you can orchestrate. It actually looks like a ADF only, like there is some pipeline, it gets generated from this to this hierarchy, this runs, and then this runs, and then finally this is done. You can do this in Databricks itself. You can directly connect to the source and then directly load it to the ADLS. So why I'm saying, and I mean, just a suggestion is, I give this kind of discussions gives a suggestion where you can actually use it in your company, or you can talk to the manager. Manager doesn't need to do that, know that we are having this kind of discussion where you got solution, as long as you are pitching the idea. That's it. So it's going to create an impact. You will get name, you'll build a rapport with, and you'll get to know more and more technologies with more and more people you get to interact. See, today initially we were two. Me and Manoranjan used to discuss all like this, and sometimes I and Shishir used to discuss. But now look at this, we have Akhil and Tarun. Maybe who knows, one day we'll be having another 20 people, maybe one day 50 people, and how many knowledge we are going to gain. I mean, it's going to be huge. So if you are discussing like this, then we'll get more and more people. Anyway, and also Tarun, we can save the cost if you're using it. If you're using ADF, I mean, if you're reducing that, then that's also a service. So you might reduce the cost. If you're using only Databricks, then it's good. You can tell this also to manager if in case he likes to add this. And Yeah, finally HDFS. So Hadoop, in the Hadoop ecosystem, HDFS is a part of it. The other two is Yarn and MapReduce. Now MapReduce is not there. It's there, but nobody uses. So Spark is, it's there, and Yarn we don't need to talk about because that's a resource manager. Now coming to HDFS, how it is actually stored. So let me calculate 5. What's 1024 divided by 4? Okay. If you if you want to store 500 MB in a HD in the big data, in the perspective of big data, if you want to store it in some storage, how you are going to store it? It's going to store the 500 MB inside one particular node, right? But let's say that the cluster in which you're having is 4-node cluster, and it can store 128 MB memory storage. That's it. Not memory, storage. If you're storing this 500 MB, how it's going to store? The HDFS is going to store by splitting the file into blocks and store each block in 4 nodes. So if you're storing 500 MB, divided by 128. So 3 nodes will be completely 128, right? And then a couple of memory will be used for the last few bytes memory, like megabytes of file. So this is how the file system, I mean HDFS, the data is stored in the HDFS. You might think that it's not we are not going to store a CSV file. Even the data, a tabular format, it's going to be converted into a file system. Now this file system will be broken into parts and then stored in different machines. If you have a 8-node cluster, then in the 8 machines it's going to store. If you have a 16-node cluster, in 16 machines it's going to store. This is how it splits the data and stores it into different machines. Now this is exactly the reason why it's called distributed storage, because all this time we were talking about distributed processing, distributed storage, but how is it distributed? Because it's going to distribute that particular thing, the data, in certain like machines. That is why it is. But okay, how is it going to retrieve them? If I have 500 MB of data, let's say that the data is in tabular format in RDB, from SQL only we pulled. From SQL table we pulled the data. The data may be in few 50,000 or 1 lakh records. Now that 1 lakh records size is 500 MB. Now when it is storing in HDFS, it is converting into a file system. Okay, understood. Let's say that the data that looks like a tabular format is converted into file system. Okay, I understood till here. Now how is it splitting? It's splitting according to based on blocks. Let's see. Hadoop 1 version was, the block size was 64 MB. So one block contains 64 MB. It used to store in machines in 64 blocks, 64, 64, 64, 64, next block 64 in another, like this. But now it is 128 MB. From Hadoop 2.0 version, the block size is 128 MB. So 128 MB will be in one block. So when it is storing this, the data which we pulled from SQL Server, into it converted into a file format. It can be any file format. See, big data, you should not talk in CSV. If it is storing, you should never talk in CSV, TSV, tab separated or something. You have to store in columnar kind of database. Columnar type of file system, something like Parquet file, ORC file, Avro, something like this. Okay, you can also store in JSON file, but nobody cares. So when you are splitting the data, that's how 128 MB is going to be in the one particular block, and that's how it's going to store in different nodes. Okay, understood. It's going to split based on 128 MB in each node. Let's say that in our example, four node cluster, Hadoop 2.0 we are using. So 128 MB is one block. Now 500 MB we bought. So 128, 128, 128, and remaining whatever 120 or how much ever is there, that's in the 4th node. Understood. It is stored. Fine, cool. Our data pipeline is good. It's going to bring that. It's going to store it. Now there is other team. Now I'm a part of data ingestion team. I pulled the data. I stored it in HDFS. Okay, good. It is distributed storage. Now somebody from the processing team is processing it. They are from data processing team who are going to do the transformations and actions. They're going to pull the data and they're going to store it. Or maybe they want to see the data. First, they want to check the data. Now they are using something called Databricks or something like that, like any tool. Now they want to check the data. They don't know coding. They don't know coding and they just know SQL. So which Databricks also gives an opportunity to write a SQL type. So I am doing, let's say the employee table stored in our 4-node cluster. It is split across the node. Now I want to do select star from employee where salary is greater than 1 lakh. Okay, too much, 50,000. Now I want to do this. I want to retrieve that. Now, how is this going to happen? Like, how it's going to fetch? HDFS is only storing data. It doesn't store schema. The file, the data, the file system contains the data only is spread across the Hadoop, the HDFS. The schema of that information is stored in a relational DB only in a tabular format. That is something called metastore. That can be MySQL, that can be anything that your data architect is going to decide. Usually it will be MySQL only. Most of the time, 90% it will be MySQL, because the Hadoop ecosystem by default, when you install it like in your cluster, they are going to give a database called Derby. That's a very lightweight Derby. Database. It's not production ready thing. Not much you could do. If you load more than 5 lakh data, it's going to fail. So that's why people don't use Derby, which comes pre-installed in Hadoop. So they are going to install MySQL. Just don't confuse cluster is different and your laptop is different. It's just that your friend, if you buy 4 laptop, then that's a cluster. They are connected through network. That's it. As simple as that. So they are going to install this SQL server, which gets installed on all 4 nodes. So they are going to unify. They are going to store some. There is something called metastore. Metastore will hold the schema of that information. So when you're storing in HDFS, data gets stored in the nodes, the machines, as a distributed storage. Their schema, like, okay, employee name is variable character. Let me store this schema in MySQL. So in MySQL, it's going to store metastore. The data will be in HDFS. When you query what this Spark is going to do, or what this processing is going to do, this whole ecosystem is going to do is brings the schema, implies on data, and show it in tabular format. As simple as that. And this is why it's fast. And this is how it looks like a tabular, it looks like a SQL, but it's not. In the background, it is a file system. That's it. So people might see Windows is slow. Why do you think Linux is fast? Because they give kernel level thing. They have more control. Why AWS is famous? Why it is doing 60%? Because more control is given in AWS. Azure, yes, classy, very good. It's good, straightforward, not much control and opportunities. And now I'm going to tell you why the project where it is, we are cross-platform. If I build a data pipeline in ADF, like I said, we were using Databricks, but the source is in AWS. Okay. Now I'm going to tell why didn't we use other opportunities? Why, Manoj? Cloud platform is there. Different cloud, latency is there. You're going to connect to the database which is in AWS, and you want to transform it in Azure and store it in ADLS. And that too, you're using Databricks. Why? Now I'm going to answer that. We built a cloud agnostic architecture, meaning in future, if we move this project in any platform, in anything, we should be able to just pick it and drop it. If I build the data pipeline by using ADF and store it in ADLS and have a cluster in Azure, store it in CosmoDB, now tomorrow the cost of Azure is increasing. That's not working out with our business. Now the senior vice presidents and chief financial officers don't want to spend more money and want to move to, let's say, AWS, where they want to move from here to MongoDB in AWS, where they want to move from data pipelines from ADF to glue, and they want to store not in ADLS but want to store in S3. It's a huge pain in the ass, data migration. How are you going to move? How are you going to change it from ADF to glue? You need to write from scratch. You cannot just pick it up and throw it over there, because this is Azure. So cloud agnostic data. Whereas why did we? Okay, this makes sense. Okay, Manoj, I cannot pick the data pipeline which is there in ADF and throw it in Azure. Automatically, magically happens. Glue doesn't happen. Okay, understood. But what's the solution? Databricks platform is given to AWS, Google, and Azure. If I have the notebook, I can export it and load that same notebook in AWS. Simple. So wherever code which is loading, which is taking the data, so only I need to change the source and the destination part in the Databricks notebook. So the source is pointing to MongoDB. Let's say that it's pointing to CosmoDB. Now here I'm going to come and point it to wherever the source is. Wherever the source is in AWS only, if it's there in MongoDB cluster, I'm going to point it there. Now here the destination was ADLS, which is again data lake. Here I'm going to point it to S3. Simple, not much change. Data migration cost effective, and it actually happened in very less time. So this is what it needs, right? Most of the project is data migration and all. So this is why our project is cloud agnostic. So this is how we are working. And HDFS, S3, ADLS, Google BigQuery table, all of them are data lake. Now, what is a data lake? You can store structured, unstructured, semi-structured. So the data where you can store different types of structured data in that particular storage, then they are called data lake. So HDFS is a data lake because it is stored in a file system. You can store audio files, video files, text files, any files, your files, my files, everything. Same thing is happening in S3. So they named it S3. That's it. It's a data lake. Azure blob, Azure data lake system also. It's the same thing. Distributed storage in different cluster. It's going to store. So that's all it is. So you have 2 minutes. Above this, the meeting is going to automatically end because we have 5 people. I cannot. This is not a pro version, so it's going to end at 40 minutes. So I hope this discussion was helpful in sort of a way. But if you have any questions, you can take it up in just 1 minute. So no questions, nothing. If you want to add something, I missed out something. If you want to add something, if you know something that I missed out, then you can add that. Everybody's in the same thing. Nobody's CEO here, nobody's hierarchy. You can add. I'm a human, I make mistakes. No mistakes. Everything I covered. If you're talking on mute, then you're on mute. Good. Nothing's left. So it's 1 minute. I think this is going to end. Where is the stop recording? Okay, guys. So if you want to do this much often, just let me know. Okay, we're going to do this much often, like this kind of discussion. Maybe we'll take another topic. Let's talk something about cloud or something. If you want to talk about Databricks, you want to talk about Zipline, if you want to talk about something else, Spark, which is a very huge topic. That's huge. So because I want to start from basics, so that's why. Anyways, thank you so much, guys, for joining in. Okay, we'll do this much often.